Hello, I'm Uday Mittal from Yaksha CSC, and in this video I'll give you a walkthrough of the Garbled Password lab of Attack Defense Labs by Pentester Academy. You can find this lab under the Reverse Engineering Static Binary Analysis, and here is the Garbled Password lab that I'll be giving a walkthrough of. So let's just start it. I'll run. So as you can see here that this is a static analysis challenge, and we can view the disassembled code using GDB, but we cannot run it. Now I have tried it multiple times, but GDB won't let me run the code despite trying many tricks. So this seems true, and it requires a basic knowledge of assembly language. Even if you have knowledge of x86 assembly, I think you should be able to do this lab, though the page says, or the mission statement says, that you need 64-bit assembly knowledge. So we have to figure out a password to run this challenge successfully, and once we have the password, it will give us a flag. So I'll now click on the lab link and it will take me to a terminal. So let's see what we have here. Issue ls. Great. I'll first run this file as it is, challenge, and I'll give it a password. So obviously it's a wrong password. So my first step is to run this file through the strings utility available in Linux distribution, and I'll grep for password. So as you can see here that we have two password variables, password1 and password2. It takes an input password. I think this should be the function that validates the password, and this is the source file that we don't have access to, so not of much use to us. And again we have password2 and password1 here. So now I'll run this file through the GDB. So gdb q for quiet mode, and challenge. Great. Now I'll issue a info variables command to check the variables that are available in this file, and these variables are of interest to us. So it says that there is a password which is of 13 characters length, then there are password1 and password2 which are of 12 characters length each, and I think this is not of much use to us, so I'll just put q. And what I'll do first is I'll print these variables using the print command. Print password. So it says that the null byte repeats 12 times, so that means this variable is empty. Print password1. Oh, great. So we have a string here. So this seems to be a hard-coded string in the file, in the binary. And let's print password2. So, and we have another string here. So looks like we have two hard-coded strings in the binary, and this password is generated using these two password strings. Now usually what I'll do is I'll put a breakpoint on main and run through the code and see the disassembled code and state of various registers. But since in this particular setup it won't allow me to run the code, I'll just disassemble the code, and let's see info functions to check what functions we have in this variable, in this file. So we have a main function, we have a print flag function, we have a string str2md5 function, and we indeed have a validate password functions. So this function looks interesting. Let me just copy it and I'll disassemble this function. Quit disassemble, paste, validate password. Yeah, and I'll set the disassembly flavor to enter. I'll issue the command again. Yeah, so now you can see the disassembled code for validate password here in Intel assembly code. So this is the function prologue, and let's walk through the code here. It subtracts 20 from RSP, not of much use to us. And now we have an unconditional jump to validate password plus 103. So let's come to this location, validate password 103. This is here. So this is comparing RBP minus 04. So whatever is at the memory location specified by this address, it is comparing it with hex 0b. Sorry, it is comparing it with hex b, and if the result is less than, it is redirecting me to validate password plus 21, which is this. And now it is moving this memory location into EAX. So as you can see in the instruction above here, that it is moving 0 in this location, in this memory address. So essentially it is moving 0 in EAX, and it is doing an AND with EAX. So 0 and 1 is 0, so EAX is 0. So test EAX. So if it is 0, that is so JE means that if it has found this to be equal, it is asking me to jump to password plus 66. So let's jump here, and it is again moving this memory location in which it had stored 00 to EAX. So it is again moving 0 into EAX, and it is moving a string into EAX, sorry, into the RDX. So it is basically copying whatever is there in EAX into RDX register. So what movsxd means is that it is asking the processor to copy EAX into RDX and then extend it to the end, and then it is moving this memory address into RAX. So this is the this is the memory address that it is moving into RAX. This is the memory address of password one string. Let's verify this. Copy, this, paste, and this is the password one string that we saw earlier. It is moving. Next is moving RDX plus RAX into 1 into ECX. So essentially I think it is moving the first character or the character at this location into ECX, and it is 0 extending the ECX register further, and it is moving this memory location, whatever there is in this memory location, to EX, which is 0 as we saw earlier, and it is again moving 0 into RDX, and then it is loading this memory address into RAX. So this is the memory address of the password. We'll verify it. Paste. Yeah, so it's a blank string, and if we come below it, it is moving CL to this memory location, and it is moving 0 1, or it is rather, it is adding 1 to this memory location, and it is again comparing it with B. So 1 is obviously less than B, and if it is less than or less than or equal to rather, then it is again redirecting us to 21. So this seems to be a loop of some kind, right? And so this time EX is 1, and 1 and 1 is again 1. So test EX will result in 1. So this is not equal to 0. So we will come to this instruction. It is moving this memory address, or rather what the contents of this memory address, into EAX, which is 1, and it is again issuing move SXT RDX EAX. So it is loading the content of EAX into RDX and asking it to extend it to the end. Now it is loading the contents of this memory address, which is this address, into RAX. Let's verify what is there in this memory address. It says password 2. Yes, correct. So we have another string here, the password2 string that we saw earlier, and it is loading a character, I think, from this uh, it's from this string into ECX and extending it with zeros. Now it is again moving the contents of this memory location into EAX, which is 1 at this time, and it is moving EAX into RDX and then loading the content of password, or rather loading this memory address into RAX and moving the contents of CL into this memory location, and then there is an unconditional jump to password or validate password plus 99, so which is again adding 1 to the EAX register, sorry, adding 1 to this memory location, which is now 2, and comparing it with B, and again it's redirecting us to validate password plus 21. So this seems like a loop of some kind, and if I were to guess, in the first part it is taking a string or a character from this string, storing it in the password, then it is taking a character from this string and storing it in the password, and this goes on. Now if I do this manually, what do we get? Let's see. So assuming that this function here is taking a character from these strings one by one and storing them to password, let's build whatever is there in the password, or let's attempt to build whatever it might be storing the password. So this seems to be the string that this function is building and then validating it. So let's try this string. Let's try our luck here. Oops, we got a wrong password. So let me just run it again in GDB for a second, and if I do info variables, we'll see that the length of password is 13, and this string here is definitely more than 13 characters. So let's take an intelligent guess, and I'll remove all the numbers from the string and let's see what I get. And it gives us the string never give up, and the length of the string is 12 characters, as you can see here. Never give up. Great. So we got a flag here. Now I have hidden the content of the flag because obviously I want you to do this lab by yourself and experience the fun of going through the assembly code. Thank you for watching this video, and in the meanwhile please subscribe to our channel Yaksha CSC and follow us on Twitter. Our Twitter handle is at @yaksha443, and if you need any further help with any other lab or CTF, my contact details are in the description below. Please feel free to contact me.